So before we even start looking at the oxidation reactions, there is one thing that I really want you to get down and have clear in mind, which is definition of oxidation, which you've encountered already because you've probably covered already redox, but this actually is already down here. This is the important definition that I want you to get in mind, because this will help us explaining and understanding better all of these changes. That oxidation it can be defined as loss of electrons. This is the one that we're most familiar with in the topic of redox, but in this case, we don't, it's a bit more difficult to look at the transfer of electrons, change in charges, oxidation numbers. So in organic chemistry, kind of forget about that definition of loss of electrons. The more important definitions are those loss of hydrogen and gain of oxygen. Because to understand that if a molecule can be oxidized, we can see if it's possible to lose hydrogen or gain oxygen, as simple as that. So I want you to look now at primary alcohols. Primary, so the classification is always really important. Primary because it's bonded to just another group that is different than hydrogen. And notice that it has two hydrogens that can eventually be removed. So this already suggests us that this carbon with the OH functional group can probably oxidize twice. Okay, notice two oxidation. Then we will look in detail what each functional group is, but now follow along just the colors. Secondary, we're talking about this carbon. Notice that the functional group is attached to this carbon with only one available hydrogen, only one oxidation. This carbon, our groups are just different than hydrogen, doesn't have any hydrogen that can be removed. So starting from kind of the bottom of the explanation, loss of hydrogens, we can see that the tertiary alcohol doesn't have any hydrogen that can be removed, therefore it cannot be oxidized. Now let's look into a bit more detail what this oxidation means. Gain of oxygen, okay, great. But it's not that we just randomly add oxygen, because we also needed to think about the functional groups that we they're a bit more common. The first step of oxidation is actually gaining another bond with oxygen, okay, because that's anyway the maximum number of electrons that can be shared between a carbon and an oxygen. So before we add any extra oxygen, we form a double bond. Carbonyl, it's one of the most important functional groups that you need to know, because these carbon double bond oxygen will make up a lot of different functional groups. We have already 3 just in this page. So notice that the first hydrogen is removed, okay, and the other bond it's formed. Actually, in total, 2 hydrogens are removed, and notice the 2 are one is from the hydrogen, one is from the carbon, and then, well, the oxidizing agent will kind of give one oxygen to form this other product, water. Okay, so summarize, primary alcohol can be first oxidized to form this functional group. And all we've done, it's the first step of oxidation, which is the removing hydrogen and adding a double bond to form carbonyl. In this case, because there is a hydrogen attached, this functional group is aldehyde. Aldehyde specifically written as a CHO to distinguish it from COH, the alcohol. But notice something. There is another hydrogen, and now we can actually add extra oxygens to form another very common functional group, carboxylic acid. So carboxylic acid is this one, written as a COOH. Okay, and in this case, we've added another oxygen. That's why it's oxidation. Okay, so one thing to notice is that there is 2 different conditions to form those 2 functional groups. So that we need to mention why, but in a second. Let's look at secondary alcohol, just to keep in mind that hydrogen oxygen discussion. So this is the functional group of a secondary alcohol, and this is what happens in the oxidation. As before, water is removed, so we lose 2 hydrogens, one from the carbon, one from the oxygen, and we form the carbonyl, the double bond. However, because it's in between a carbon chain. This functional group specifically, it's called a ketone. COC as a short. So it cannot be oxidized further because notice that on the functional group, they highlighted in yellow, there is no other hydrogen that can be removed. Carbon has the maximum number of bonds. That's it. That's where it stops. So summary, primary can be oxidized to aldehyde. Aldehyde can be oxidized to carboxylic acid. Secondary can be oxidized to ketones. Tertiary cannot be oxidized. Now let's look into more detail why we have two different steps. One, distillation, and the other one, reflux. Let's see what this means. So those are two different techniques. Distillation consists in the separating a substance, so separating substances with different boiling points. Okay, and here it does require a little revision of intermolecular forces. So look at the apparatus of distillation. So distillation, so actually before that, aldehydes, they have a much lower boiling point compared to primary alcohol, simply because, I'm reading here actually, because they don't have hydrogen bond. Okay, so as soon as the reaction takes place, so these, imagine we're heating at, I don't know, 60 degrees, that is the boiling temperature of an alcohol. But this has a boiling temperature of 45 degrees because, well, weaker intermolecular forces. So as soon as the aldehyde form, it evaporates. In the distillation apparatus, it has a way out in the condenser. Okay, in the condenser, it condenses and it's separated in a different flask. So with distillation, we can obtain the aldehyde, simply because as soon as it forms, it evaporates and it's separated straight away. Okay, but in the reflux is different, because if the aldehyde is formed, it evaporates, but then it condenses over here. There is no way out. It condenses back down in the flask, in contact with more oxidizing agent, and that's why the oxidation would continue further. So if we have a oxidation of a primary alcohol under distillation, we would get an aldehyde because it can be separated. But if it's under reflux, the reaction would continue up to the end, so we would get the carboxylic acid. Okay, so that's important to remember, because a different condition would result in different products for the oxidation of primary alcohols. Okay, while the ketone, no, wrong way. While with the ketones, reflux it's used, which it's the most common technique, the synthetic technique in organic chemistry, because it simply means we prolong the heating. And it's quite important if you think about it as a technique, because organic compounds are normally really flammable or volatile, but these are, which is a closed apparatus, well, if something evaporates, it would condense back because the condenser cools it down. But also there is no there is no flame that is in contact, that could get in contact with the organic compound. So it's definitely a safer technique. That's why it's really, really common. Distillation a bit more specific, if there is something that can be separated due to the difference in boiling point. And one last point to mention is that there are changes in color, because those are the two common oxidizing agents. Potassium permanganate, it changes from blue to, from purple to colorless if the oxidation takes place. While the acidified potassium dichromate, it changes from orange to green. So this is not only, well, the oxidizing agent, but is also a test that could help us distinguish between the different compounds, right? Because tertiary alcohol wouldn't react, as we said, it doesn't get oxidized, so there wouldn't be change in color, while primary and secondary would react. So it's important to notice that, because there would be a whole topic on organic analysis, yeah? And very often the reagents are actually also test tubes reaction for some functional group. Okay, so I hope it's clear in terms of changes in functional group, conditions, and of course definition of oxidation, and fully understand how the oxidation takes place.